All right, welcome to a video lesson here on properties of trigonometric functions. I'm going to be digging further into the properties of sine and cos as functions that I introduced in a previous video lesson here. So the first thing I want to mention is that sine and cos are part of a family of functions that are referred to as periodic functions. So a function is considered periodic if it has a pattern of y values that repeat at regular intervals. So we saw that when we graphed sine and cos, that we have this sort of repeating pattern as we move from left to right, and that happens for the graph of cos as well. Sometimes sine and cos are referred to as sinusoidal functions. Sinusoidal also means periodic, any function that repeats in a regular interval. Okay, a term that we use to describe periodic functions is a cycle. This is one complete pattern. So you can see on this graph here, this red portion, this is one complete pattern before the pattern starts over again. Okay, you can see I've got another one here. Starting at 10 and I finish at 14. As long as you can pick out one complete pattern, that's considered a cycle. Okay, a period is this is what we call the horizontal length of one cycle. So if you move from 1 to 5 here, that's the length horizontally, so we call that the period. Okay, an amplitude, this is half the difference between the max and min value. You could represent this mathematically as max minus min over 2. Calculate the amplitude just really quickly for this graph. Our max value is 2, our min value appears to be -1, so 2 minus -1 would be 3. So 3 over 2 would be our amplitude, so 1.5. So if you just picture for a moment, if I let's say I'm looking at this 0.5 point right here, if I just draw a horizontal line, there's a distance of 1.5 units from this horizontal line to the max, as well as from the horizontal line to the minimum. So this horizontal line sometimes is referred to as the equilibrium point, and you may hear that moving on into your studies of periodic functions. Let's just look at some examples here, and I just want to classify these functions as periodic or not. And if they are, we're going to try to state the period and the amplitude. This first one here definitely looks to be periodic. If I just pick a random point, for instance, well, let's pick this point right here, 0, what looks like to be 0, 0.5. It takes approximately, let's see, we'll say this is what, 5, 6, approximately 6.5 to go through one full cycle, and then we start repeating again. So this would definitely be considered a periodic function. We've got a period of about 6.5. Sorry, I should have chosen a better graph with an easier to understand axis. But you can see that this is definitely periodic. It continues to repeat in regular intervals. Whereas this graph here definitely is not periodic. Okay, there's not a regular pattern in my y values as I move from left to right. So I'm going to say this is not periodic. Okay, last one here, definitely another periodic function. If I start at 0 here, 0, 0, it appears to be going through one full cycle in about 6.25. Okay, so there's definitely a repeating pattern of y values there. So that would be the period. Also, we're supposed to state the amplitude. Sorry, I'm not reading the question. Amplitude appears to be 1 in this case, the distance from the max to the equilibrium point and the min to the equilibrium point, or max minus min divided by 2. Our amplitude is tough to tell in this graph because, again, I chose a horrible graph, but it looks to be about 1.5 from the central axis or the equilibrium point to the top, the max or the min, likewise. Okay, so an amplitude of 1.5. All right, so just a little problem here I just want to go over. This is one of my favorites to put on tests and quizzes. So you're given the graph of a function here. It says if f at x, that's this function being graphed, is periodic. So we know this thing is periodic, and you can kind of see that it is in fact. And we know that if we were to substitute 2 into this function, we would get 6. What do you expect f at 16 to be? So this is really a great question because it challenges you to think about what periodic means. Well, we know that periodic means this thing goes through one full cycle in some number of units. So what we're going to do is we're going to pick out the period here just by looking at this graph. So what I've done is I've highlighted this point here, f at 2 equals 6. And I want to see how long it takes before I get another value of 6. So I've got this other little marker. As it turns out, it's this point right here. You can see these 2 points are identical. They have the same value of 6. Okay, this point here would also have a value of 6, but I haven't quite gone through one full cycle. if I put my point there. So I'm gonna choose this point here. You can see I've gone through one full cycle and then I start repeating. So what I'm going to do is I'm going to calculate the horizontal distance that it took for that to happen. Okay, so I started at 2 and I finished at 9, so that must mean that my period is 7. It took me 7 units to go through one full cycle. Well, if 7 is my period, I could add 7 to my initial value of 2 and say f at 9 is also 6. Okay, so that's what I've done here. I've shown you that if I substitute 9, I get 6. Well, from that, we can conclude that if we add another 7 to 9, we would get 16. We'd get the value of the function at 16. That's what we're looking for here. We want to find out what we would expect our function at 16 to be. Well, we can expect the value of our function at 16 to be 6 based on the fact that this function is in fact periodic. Great question, great test or quiz question. So if you're one of my students, there's a little hint there for you. All right, so that's the end of this video tutorial on properties of trig functions. Really brief. I just wanted to introduce those terms: cycle, period, amplitude, periodic function. These are things that you're going to be using, especially as we move on and start looking at transformations of trig functions.